Okay, so good afternoon, everyone. Thanks again for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course and it will be posted on our on-demand page. We have Jennifer Rennick and Paul Dunn with us today to walk us through residential compliance forms for occupancy. But before we get going, I just have a few slides. Just a friendly reminder to keep yourself on mute. If you have a question, please raise your hand and we'll call on you to unmute yourself, or we'll be monitoring the chat box as well, so we'll be able to get your questions answered. And a few words about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the public goods charge found on our utility bills. And 3C Ren currently offers 3 programs. The first of which is our Energy Code Connect program, which this course is brought to you through. And this program offers our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions for both residential and non-residential projects. And then we have our Building Performance Training program, which serves building professionals by offering technical and soft skill trainings relating to building science principles and high performance buildings. And then we have our third program, which is our Home Energy Savings, which incentivizes contractors and helps residents save money to make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Jennifer.
Hey, everybody. I'm Jennifer Rennick. I'm a licensed architect and a certified energy analyst with Imbalance Screen Consulting. And I'm joined today with Paul Dunn, and he's HERS 1 and HERS 2 rater, Central Coast Energy Compliance. And Paul, you want to give a shout out, say hi, say anything else?
Yeah, sure. Good afternoon, everyone. My name is Paul. I've been HERS rater since 2005 code. My first job walk was sometime in the spring of 2007. So I've been at it about 16 years. My wife is a CEA, and together we have Central Coast Energy Compliance. And let's get started here. This will be fun.
Okay, today's real quick. If you're AIA member or ICC, there are some pending learning units, and you can reach out to Sarah. The pending meaning she's in the process of getting the paperwork done. So I'm sure you'll get learning units for the courses once it's completed.
Those are officially approved as of yesterday, so we're good.
Okay, we're good. So reach out to Sarah to get those units. We did a class just recently, just a few weeks back, and it was the overview of the forms for residential single family construction on the permitting side. So we mostly were talking about the CF1Rs to show compliance with the energy code and kind of give everyone a heads up on what maybe a plans examiner would look at, and also to give architects and others just an overview of what these forms look like and where you would find the information you need for your project. And today we're going to specifically look at some of the CF2Rs and the CF3R forms for installation requirements and the verification requirements. The California has HERS, and I could tell from most of the chat, probably most of you know this already, but in case we get a few new people joining, and also because it's being recorded, might be posted to the website, I'm going to review that HERS is Home Energy Rating System. And in California, we have 2 HERS providers currently, CalCerts and Cheers. And these are the organizations who are responsible for certifying our HERS raters and supporting the California Energy Code HERS registry. And so the process big picture process is you submit for design for permitting, and you'll have your CF1R compliance report created and uploaded to the HERS registry. Then during construction, you're going to have your CF2Rs for installation completed, uploaded to the HERS registry. Your CF3Rs verification completed, uploaded to the HERS registry. And then the building official can confirm your CF2Rs and CF3Rs are uploaded and signed, and CalCerts has what's called the PSR, and we'll take a look at that slide coming up. And once that process is done, then you can get your final occupancy. On CalCerts, this is just an example from a project I have on CalCerts. What I could see on my end as an energy analyst is a list of the CF2Rs and 3R forms that would be required. This is not an exhaustive list, but these are the ones that populate for the particular project I was working on. And you'll see like electric ready requirements. CF2Rs required? Yes. CF3Rs required? No, it's not applicable, etc. What we're going to see with your plans examiner. So I think we have a plans examiner in training. What a lot of times you end up seeing on the planning and building side, if you go onto the CalCerts registry, is this PSR report. Okay, Paul, jump in and tell us a little bit about it.
Okay, this is usually seen towards the end of the project when you're calling for final. So Jennifer, can you back up 2 slides?
Yep.
Let's go one more. Yeah, here. So this is the theoretical flow of things, but oftentimes as a rater, I get called right before final because the agency is asking for certificates and paperwork and so on. So to make it go more smoothly, us raters would like to ask people who are creating energy complaints documents to communicate to their client, i.e. builder, architect, whoever, that this needs to happen. And in fact, let's try to put it right on the plans so that, you know, this special inspector known as a HERS rater can get in front of it and communicate with the various subcontractors what needs to happen so everything flows smoothly, so we don't have any hiccups right at final when the people are sitting in their moving van outside on the street, you know, and we're waiting to get finals. I've literally been in that situation before. So skip ahead 2 slides. And at that point in the game, say the building official is looking at the project summary, he wants to see, for the most part, what we call all green dots. Right. So that indicates to them that all the subs and their responsible forms, the CF2Rs, have been completed either by the sub or the rater on behalf of the sub or the general contractor, because they can oversign pretty much anything in terms of an installation certificate. As a service and as a HERS rater, I generally do that on their behalf just to make it go more quickly. And then we ask that sub to go into the registry and approve that data that's uploaded on their behalf by me, because I'm at the site anyway, collecting data and uploading it in the comfort of my office come close to final. So we're ready for the next one.
Okay, and the kind of questions as energy analysts and consulting to builders and architects, one of the questions that come up is, well, how do I know what these forms are? What are the requirements? What are you talking about? And it seems like a lot of it is learned through kind of trial and error and experience. And I've even had architects and builders tell me, oh, well, I've learned what to do because I get the corrections on plan check. And so over the years now, I've learned what I'm supposed to be doing. So we're trying to be proactive and guide folks to the CEC's, California Energy Commission's website, where they have the supporting documents forms. And this particular 2022 supporting documents -forms -residential, like that's the where you need to navigate to. Oh, and I noticed we had a couple, there were like 1 or 2 people from the CEC. So my feedback is there a way to not bury this so deeply into the website? Say that with like a question mark, because I know redoing a website is like a big deal, but it would be cool if there would be a way for folks to navigate to this without scrolling down, and because they ask me and I'll point people to it. But anyhow, with that said, you can get a look at the CF2Rs and the CF3Rs that are for informational purposes, and they're also a great resource of what the requirements are. Today, however, we're only going to focus on some of the measures that deal with the envelope and some of those measures that deal with mechanical. So to give you an idea of what this looks like, when you click into the website on envelope, for example, these CF2R and CF3R forms populate in a list like this, and you can click on this list and click on each item, and then you will be able to download that informational form, watermarked informational purposes, but at least it gives you all the information. Today, specifically, we're going to take a look at the form that deals with the insulation installation and the corresponding QII, quality insulation installation forms. We're not going to be able to go into detail, but we're going to highlight these forms. And then we're going to follow that up with the building or enclosure air leakage forms. And then this is what the mechanical looks like just for the CF2R. First time I ever looked at this, it was overwhelming to me. So, but then when I dug into it a little deeper and started to organize it in my own mind, so maybe even a formatting issue if the CEC has control over this, is maybe just even like separate it out a little bit so you could see more easily that it's really not that many, in the sense that there's groupings, like it's the MEC 1 series and for different conditions. And so you all going to get a copy of the slides, maybe share it with other folks that you work with. This may help them kind of see the hierarchy in it. And then today we're going to hit on the forms that deal with QII and building enclosure, which overlap with that. Then we're going to go into a little bit about duct leakage testing. What is it? And there's supporting forms that go with that. And we're going to take a look at local mechanical exhaust, kitchen hoods specifically, just that one, and a little bit about variable capacity heat pump compliance credit, because that's a great credit. And specifically, we're going to look at duct leakage. And these are the supporting for that are highlighted like in mauve is how the color looks on my screen that support that. Some of those other forms, of course, can be triggered with other systems like refrigerant verification charge, refrigerant charge verification. Okay, so just the CF3R, same thing. There's a hierarchy to it. There's a grouping to it, and we'll hit on the building leakage, enclosure, duct leakage, local mechanical exhaust, variable capacity heat pump credit, and those supporting items.
If I may add.
Yeah, absolutely.
Yes, so to the audience, don't let your eyes glaze over. There are a lot of forms there on the previous slide, but a lot of those forms are just kind of hovering in the background. You'll probably never have to deal with them. Your HERS rater will upload what is pertinent to the project. And if there's any questions early on in, say, CalCert's training, for example, they use the term rater as educator. So that rater should be able to explain to you, okay, here's how we're going to complete this form. Here's who's going to do it. And this is going to be the process. So don't get bogged down in, 26 forms on a screen. Really only 2 or 3 of those for the most part are going to be the most important for your project.
Right.
Yeah.
And yes. And when you share this kind of this information with other folks, for those of you who are also HERS raters or HERS rater and plans examiner in training, really what I wanted to show you is that that information is available on a website. So if you know from that HERS rater what you need or what kinds of things you're going to be looking at, or you could share this with the architects as well, because sometimes there's information in that they can get into their drawings to make their world easier, but they won't go through the whole list. So you maybe help them by targeting specifically what they need. So in general, when you take a look at the CF1R performance, I'm going to be using performance CF1R as an example. We, in the last class, talked about the HERS feature summary, special features summary that's in the beginning of the report. We're going to use that as kind of a way to key in real quickly what's going to be required. So CF1R HERS feature summary. In this case, we're going to talk about quality insulation installation. And it's noted that quality insulation installation, QII, is required. Okay, Paul, take it from here.
QII is a real biggie. So if you are prescribing QII because you need to gain compliance, you have a challenging design. And so you say, okay, let's run QII in this. Oh, okay, now our EDR is, passing by whatever it is. So the ramifications of that is that you have to really have on board a number of trades, starting with the framer. You probably may need to enlist electrical and plumbing and so on, and your installation contractor as well. So get ahead of it early and inform the actors involved in a project to get on board with the rater so that there's no hiccups down the line. There's a number of checklists for that. There's a great little handbook that CalCerts produced some years ago. This is 2019 code. I'm sure they have one for 2022 code. It's really the same type of
Paul, show
topics.
it up in your camera.
Yeah, see, did you get that?
We should have done a clip.
Can you everyone see that?
Hold it up higher. Yep, that one.
Okay.
I don't know if you can see it, but
I don't have my other camera back on because I can't see all the screen. Anyway, your rater should be able to walk you through that process as well. So again, we just want to get out in front of it so there's no problems down the line. In the framing aspect of it, because really QII is two major avenues. The first one being air sealing, the second one being the actual installation of the material. Under air sealing, if the rater can walk the job and say, okay, we have a unique framing situation there, here's what we're going to need to do to get in front of that. It is really helpful so that there's no problems down the line. My example to Jennifer before, and I see this a lot on jobs, is say in tract homes, you'll have a lot of preformed fiberglass shower inserts. A lot of times they show up on the job really soon, right after frame, but we want to make sure we have an interior air barrier on the other side of that tub to make a, QII style sandwich so that we have insulation contact on all 6 sides of a framing cavity. So let's get some kind of approved air barrier on the inside of that wall before you set the tub. Again, that's why we want to walk jobs really soon in this process.
Okay. And Paul, one of the first forms, I mean, this one here, insulation installation, it's a non-HERS. It could be the installer or the GC. Yes. But I understand that a lot of times you'll help folks get this completed. And the reason I like to, I sometimes print this out and I remind folks about it because it's just chock full of really good reminders and information on what it's going to take for QII.
Yes, I'd agree. I think for the most part, the insulation contractors that I work with in San Luis County, they are good with their CF2R ENV 03 because they know what material went to the site. And I think through years of training, I've gotten them to go ahead and upload that form. I chase it later, of course, with my CF3R ENV 21 and 22, which is kind of like the current forms for QII. And so then it all kind of dovetails nicely.
Yeah. Okay, and Paul, we got a question comment in the chat, and it's about, the multiple QII inspections, and the building inspectors need to be on watch for, like, i.e. ref framing and mechanicals, post installation, post drywall, etc. Yes. So for example, this first form here, the ENV 03, okay, yes, it addresses basically insulation installation, but kind of prior to that, even though it's ENV 21H
Right.
CF2R, this one got to address the air sealing. It's part of the
Yes.
QII, but a lot of this was going to come before the actual insulation.
Amen, sister. So make sure that this gets eyes on it before you start rocking your job, drywalling your job. Radar needs to be there um, before you do that. And so I really think that the radar at a minimum has two, most likely three visits to the site, kind of like a pre-walk, an air sealing inspection, maybe a fourth, and then a day of installation inspection, and then kind of a final when they come back to do maybe other measures. They can verify attic insulation at that point, and to make sure that they're meeting their R values and that all of the boxes are checked. Yep.
Okay. And another great resource is the U.S. Department of Energy's Energy Efficiency, Renewable Energy. If you go to their website, they also have a great resource for just how to do air sealing, and especially air sealing for retrofits, which I find handy. And yes, Xavier, yes, one of our fellow HERS raters says he does a PowerPoint for his folks at that review / construction on-site meeting. That's good. That's cool. And then continuing on with some of the CF2Rs for the air infiltration, air sealing. These are, that's a great picture that Paul shared with us from one of his job sites. It specifically, for new construction and alterations. And in alteration situation, I did a graphic down at the bottom right hand for folks to know that sometimes when you're doing those altered ceilings, and it's in this QII list, if you can't access, if those lights cannot be covered, if they're not ICAT rated, insulation cover rated, you can buy a box or create a drywall box with continuous fireproof sealant, keep it 3 inches off the light fixture, et cetera, lump up your insulation over it, and continue on with the QII. Anything you want to add on that, Paul?
Yeah, I do. One little caveat is fire sprinklers. Some manufacturers do not want you messing at all with their penetrations because there's some requirement, the way they install things. So item 03 on that checklist, you might have to kind of dance around or at least work with the manufacturer to see what you can do to seal those penetrations. There are kind of new designs coming out for fire sprinkler systems, and that probably needs to be done on a case-by-case basis.
And Paul, a lot of those things, these are the types of things you would cover in that meeting when you get those team players on site. And if you know that, for example, it's a retrofit, or if you know sprinklers are going into that project.
Correct. Right. So on this slide, this meeting that I had with the installer ended up being not passed down to the actual installation team, and they came in blue and some cellulose, but it really didn't quite meet the measure, so they had to come back. That's what we're looking at here with my piece of plastic that I've kind of used as a quick and dirty tool to kind of quickly measure insulation depth.
But
and
they
people
did
hate,
do it.
I'm sorry?
They did come back and do it. And we
Oh,
have,
yeah,
and
of
you have
course.
that CalCerts watermarked
Yeah,
CF3R for
right,
it.
right. And they hate to come back, but they learn pretty quickly when they're losing money or breaking even or whatever, because, it is what it is. You have to do the minimum. It's not that
Okay.
difficult.
Right. And then, so, I mean, this is kind of the basic kind of review of the process for the QII is those CF2Rs, CF3Rs are complete and the project can obtain the final occupancy approval. Of course, your HERS rater works with everyone and they see the watermark on all those and the authority having jurisdiction will see a pass on the list of required forms. And we're gonna now move into the building enclosure, air leakage. And this also hits into some of the envelope ENB forms and the MEC or mechanical forms. And again, on that CF1R, you look at the HERS feature summary, and in this case, building air leakage, reduced infiltration is required. And if you go further into the form, you're going to see your building envelope HERS verification. It's kind of a little bit of a cheat sheet there. And in this case, yes, this particular project will have building envelope air leakage required. And in this case, we were having a very tight house. So we got the air changes, which are measured air changes. That means the changing of air of the whole volume of the space down to 2 air changes per hour. And there's several CF2R and 3R forms that go with it. And Paul's going to dive in a little bit more on kind of that HERS workflow. And then he's going to tell, we have a great slide for building air leakage testing in case that's new to anybody on the call.
Sure. I just saw a little question about, is it standard procedure to have a pre-con meeting? And I am saying, yes, please. Let's have a pre-con meeting if the EC is asking for QII. That way, everyone's on board. Also, I want to address one little issue with standard QII in a tract home development. I'm very much against sampling protocol for that because if given the opportunity, I found the trades will do less than they need to achieve QII. And so, for example, in the few tracks that I've run, I pretty much just promote 100% testing so that the consumer gets what they're paying for, and that's a thermally efficient envelope and QII level insulation. Okay, so for air sealing, blower door testing, not as big as a credit as it used to be, I understand, but in order to, well, let me back up. From multifamily, of course, we have compartmentalization testing where we use a blower door to test the air sealing qualities of each dwelling because we don't want air sneaking into the adjacent dwelling and so on. So in order to ensure that we pass that, we have to do a really good job at air sealing. So that's your sole plate, all your penetrations, so on and so forth, so that there's no communication between dwellings. And in a single family, say custom, that is thermally efficient with no air going from nasty places to good places. So I think that an air changes per hour of 2, Jennifer and I discussed it yesterday, that's a pretty tall order in standard construction techniques. Not that it's not impossible, but it takes a lot of attention to detail. Okay, so here we have the standard blower door test that I ran some months ago, and that's the equipment that you see carted around in my work truck, and which is a Toyota Prius. And we fit the blower door in there along with other tools. And standard stuff here, this is a pressurization test because we are putting our fan facing in towards the building. And pressure probes are run inside and to the fan itself to generate our data that you can see on the upper right of that slide.
Right. And then for those of you who are not familiar with it, I mean, it's part of that whole protocol that it's pressurized to 50 Pascal, and then you measure the air leakage in cubic feet per minute, CFM. So in this case, 971. But for the size of the house, it's pretty good. But it's probably, you said like 4 air changes per hour. So you probably wouldn't get a very big credit on your compliance report. So as an energy analyst, what I've noticed is that if I have clients who want to do building air leakage testing, I make sure the whole team is ahead of the curve on it, because what we've seen in the past is folks will dial down the building air leakage tests to try and get some points that way to pass their compliance point, maybe to make up for having a lot more glazing than the standard. So they want more glass, but a tight house. And if the builder doesn't meet that, if they're unable to get the house tight enough, then someone like Paul goes out, tests it, doesn't give them the credit they need, then they come back to the energy consultant to rerun their Title 24. And sometimes we scramble to look for other things that can be changed or updated to give them credit. And it's really hard when the project's been nearly complete construction. So
yeah, so now there you are, the EC trying to backfill a Title 24 to get it to comply, and say the EC from another area prescribes that measure, but the house is on a raised floor and it's got tongue and groove ceilings. I'll tell you right now, that is a very porous type of structure. And you generally cannot get good numbers for your blower door test.
yeah, and stuff like that, right? I
Right.
get that question a lot from architects. Yeah, that's a really good point. They'll say, oh, hey, do I have to have drywall up before we do the tongue and groove ceiling? And I tell them, well, I pretty much just say yes now. I just shortcut the discussion and just go, yes,
Okay.
you need to. Because
Right.
first we need an air barrier. So where's your air barrier? I have to make sure, is it the interior drywall, or do you have a whole roof construction system? But we'll kind of look at that a little bit on our very last slide, actually, on air barrier.
There is some emerging technology there, in that I think there's a service that's running around with their fogging device that can essentially fill in the cracks, either at frame or after frame, to make a house tighter and tighter and tighter. There's a concessionaire in this county that does that. So it is possible to get, drill it down to really tight envelope. You just have to put more money into it and a lot of attention.
Okay, I'm going to move on to this slide, but
Okay.
Paul, can you take a look at the chat? I think I don't understand Judy's question, and I don't think I have an answer for George's question, but maybe you can help me out there. So this kind of rolls into part of the air sealing, is it naturally can roll into the duct and HVAC leakage testing if you have a ducted system. And kind of follow on with what Paul said, one of the projects Paul and I worked on some years ago, we had to go back and find credit, and we ended up, Paul said, well, how about a low leakage air handler? Because they hadn't put the air handler in yet. And turns out that helped. So we're able to suggest it, and it worked. But again, take a look at the HERS feature summary and see what's being triggered. In this case, duct leakage testing, low leakage air handler unit. And just FYI, these when you do that, when you're reading these CF1Rs, you're going to see a lot of these other HERS items that are also triggered that go along with these credits. And you go back to the HERS distribution, HERS verification portion of the report, and it'll say duct leakage yes, target percent leakage 5% in this example. Low leakage air handler required, yes. And then we have the corresponding CF2R and CF3R forms that go along with it. And Paul Scott duct leakage testing equipment. This is one of Paul's sites. or
Yeah,
projects?
this is Grandpa, my original duct blaster. It's an older unit, but it is inspected and certified and tested and calibrated and so on. Um, this is my bragging point. I've done over 3,000 duct leakage tests in the past 16 years. I can pretty much do it with my eyes closed. But and it's not just duct leakage, of course. You know, there's HVAC testing, which is kind of more common in the valley. In our climate zone here, 4, 5, and 6, we just started doing duct leakage testing, 12 years ago. Then the other tests that can be done for above code measures like refrigerant charge and airflow and fan efficacy, those kind of came along for the ride, but now they're more standardized here as the code, increases in stringency. So it is more common now for me to do refrigerant charge and so on and so forth. But anytime in our climate zones we have new construction with cooling, we have to do the airflow and fan efficacy testing.
And then deck ceiling alterations, what you might end up seeing on the CF1R, again, HERS feature summary. You can see some duct sealing required if a duct system component, plenum, or air handler unit is altered. Okay, so it's like, hey, heads up. So similar CF2R and 3Rs, in other words, it's still part of the MEC 20 series, but now we'll be looking at a couple of them that were specifically set up to test for existing construction and sealing accessible leakage. And there is kind of a workflow to this that Paul's going to review, and we're going to take a look at what the quote unquote smoke test is. Although it's not real smoke, it's theatrical fog.
Okay, right. So in an alteration situation, the so-called change out, or say a system was altered in some degree, a lot of times, say someone wants to add a room or convert a garage or whatever, and then the installing contractor extends some duct work that's more than a certain length or whatever. And well, that may trigger a duct leakage test. And so say, for example, the existing ductwork has been in the attic for 30 years. You're not quite sure what kind of condition it is in, especially if it's in climate zone, 5 or 4 over the grade. And, in the summer, it's got 150-degree attic. In the winter, it's 26 degrees or whatever. So a lot of times ductwork doesn't survive in that environment for, 3 decades. So you start out with a standard duct leakage test at the current alteration criteria. It's a 10% leakage test. If that fails, the rater goes to a 7% leakage to outside, which is where you combine your blower door device with your duct leakage tester. And long story short, you're able to determine how much leakage is inside the pressure boundary versus outside with the 7% maximum. If it fails in that instance, then we introduce the theatrical fog to the system with an HVAC technician on site to basically track down any leaks that he can access and seal those in accordance with the protocol. So I've done maybe a dozen of those in the last 16 years. It's not as easy as it sounds, because a lot of times I've found, say you have a technician in an attic, and now you're basically injecting this theatrical fog into the system. It doesn't really usually come out of one pinhole. It's kind of like all of a sudden you just see like this fog kind of just occupying the attic. So they really have to get down and dirty and really use their hands in addition to feel where air might be coming out of a TY, a joint, the air handler itself, plenums, and so on. So it's kind of dicey, but it's the last dish effort to make it seal as best as you can.
And then, Paul, I put in a special box there, just reminder. Yeah. It's a big deal too if
yes,
the garage ducts.
Big deal there, because that's really health and safety of the occupant. Because if you have, say, return side leakage in your air handlers in the garage, and you've got a can of WD-40 open or whatever, you could be essentially, introducing contaminants into the dwelling. So the protocol is that you, when you're doing your smoke test or your fog test, that you really make sure that the air handler, any ducts, plenums, and so on are really sealed well in the garage area.
Okay, and then keep going. This
So
is
here we
like
are.
new construction.
Yeah, back in the day, people just put their boots, on top of the drywall, and they left the site and they came back later and put on the grills. Studies have shown that there's a significant amount of leakage at that interface where the terminus of the duct terminates, say, your standard sealing situation. So this is a box every rater has to check and visually verify at the job that you've done a good job sealing those terminations. A lot of installers prefer to use some kind of tape. I think that some kind of caulking would do a better job, but HV installers, are just more common or more comfortable using a tape. The language is sealed to the drywall in the code, so it really doesn't matter as long as it performs. I think for longevity's sake, I would prefer some kind of latex-based caulking, but it really doesn't matter. Is it sealed? Does it pass? That's what we're after. Same goes for what's up in the attic. This is just good workmanship. You want to make sure that ductwork is substantially sealed down to like 0 CFM coming out of what looks like the supply plenum. And there's the mechanical code that they must comply with, which I think recommends or specifies that there's a drawband on the inner collar, in addition to a wrap and a half of UL approved tape and or mastic, and then the outer insulation collar goes on with the same, a drawband and a wrap and a half or additional mastic, to really make sure that that thing is going to be on there for a number of decades.
We with this whole thing, you're going to have like that MEC 1 form, but it's got the E on there, meaning your HERS rater doesn't have to deal with this one, but a lot of times they will. And then that'll be followed up by like the fan efficiency and then the system airflow rate, which uses a flow capture hood. Right. And I didn't have a picture of Paul doing this one, so I, borrowed this one from the manufacturer, Canamax. But we're not brand specific here.
Right. The reason why Paul doesn't have a picture of him taking an airflow measurement is I didn't have a third hand free to take a picture. Now, these two forms are important because really these tests are hand in glove. They have to be done within 5 minutes of each other. You measure your airflow first. You get your readings, say on a 3-ton system, you need to move at least 1,050 CFM, i.e. 350 CFM per ton of cooling. And then you put down your device and you go either out to your revenue meter, or you say you have an inline watt meter in the attic that takes the pigtail plug from the air handler, goes right through your little kilowatt style watt meter, and you take that measurement down, and then you divide the total number, you divide the airflow by the number of watts, and you get a calculation. So current code is for standard split AC, you cannot have more than 0.45 watt per CFM when you're running or calling for cooling. What do we have a question here? Okay.
I think we have a couple comments so you can take a look at. Okay, so we're now from those kind of MEC forms. Now we move into the local mechanical exhaust. Specifically, we're going to talk about the kitchen range hood here. And part of the reason for that is because if you take a look at that CF1R, you see it in the HERS summary, and that a kitchen range hood test is going to be required. However, there isn't anything else in the CF1R that tells anybody how much ventilation, what size of range hood's going to be required. It's in the energy code. Your energy consultant can figure this out for you. And so for folks that are dealing with architects, or if you're energy consultant, maybe remind the architects or the builder that you can calculate this for them, or teach them how to do it, because otherwise what we're finding is just folks in the field aren't necessarily meeting this, and it's putting kind of pressure back onto the HERS rater if the builder doesn't realize that it's not really spec'd out. Because a lot of times some of these appliances, like a kitchen range hood, is just left to the homeowner, but the homeowner doesn't always know to ask, what should they be looking for? So kind of as an example, here, just taking this as example off of the already CalCerted form, but your kitchen is, say, non-enclosed, and the total unit dwelling floor area is 1,000 square feet, so it's an ADU, and it's an electric cooking stove. Go into the energy code, and to use table 150.0G for non-enclosed kitchen. So you would enter the table by the dwelling unit floor area. And in this case, it's 1,000 square feet. So we're just on the high end of the 750 to 1,000 square feet. Go over electric range hood versus natural gas range hood. And under electric range hood, the answer would be 55% capture efficiency, or 130 CFM or greater would be in compliance with this requirement. And if any of the folks on the call are not familiar with this table, which is new to the 2022 code, notice how the larger the floor area, the smaller the CFM, or smaller capture efficiency, is needed for both electric and gas. And also notice that the gas range hood does require higher capture efficiencies and higher CFMs to comply. There's been a lot of tests, a lot of studies by the EPA and others that we know that natural gas ranges, propane ranges, still emit harmful chemicals and still emit gas, even when they're off, even with electric starters. They just are not tight enough. And so that's why there's recommendation for higher capture efficiencies, and also sometimes continuous hood with a continuous low level evacuation or exhaust. So Paul, when you get out to the site, you are looking for specific things, and tell us a little bit about what you look for. And these are pictures from Paul on the job, by the way.
So, right. So to answer the chat, he's right on top of it. We want to see the HVI label or AHAM label. And as a rater, you go to giant, huge Excel spreadsheet that's maintained by these agencies that has the model number and its rating for sound measured in SON, and what it's rated for in airflow. So I've turned away jobs where the guy just went down to Home Depot and got the loudest, crappiest kitchen hood fan he could find for like $69, and put it in his ADU. And you turn the thing on, and it was like you had to go outside to change your mind. It was just not good. And so he had to send it back and get something that's met the measure of the code. So that's important. And so I think for the energy consultant to relay that to, especially to say like a homeowner builder that's going to be going out shopping on their own, what they need to look for so they can comply. And there it is.
Perfect.
Right.
And the last kind of credit we're going to look at is the variable capacity heat pump compliance option, which I forgot to put at the top of the title. There is your MEC 33H series, or rather CF2R, CF3R. And then there's a few other of the CF2R and CF3Rs that go along with it, or that naturally triggered. So it's interesting. This one shows up. Oh, let me back up. The variable capacity heat pump compliance credit. As an energy consultant, we're finding this credit gives us a very big boost, gives us a bigger margin, more than a lot of those other credits. So we're finding that we want to take this one, but this credit is rather entailed for what has to happen with the HERS person, and it does impact the architectural design. So we notice that we're really having to work with the architect first to get a bunch of stuff on the plans, and then coordinate with the builder and make sure everyone's on board before we finalize this, even though we of course have uploaded a draft CF1R, essentially a draft CF1R to CalCerts, because we don't know sometimes if this is going to go through. Anyhow, with that said, you're going to look under required special features. The variable capacity heat pump compliance option shows up at the top as a special feature, and it's going to be listed under your HERS featured summary, and it basically includes all of these. And in this case, for the ductless units, ductless indoor units located entirely in conditioned space, it also triggers the refrigerant charge verification. And part of that is that Paul's going to talk a little bit about that, is we want your HERS rater out there right away, because, and I can tell you from experience, those mini split ductless systems can be installed within just a few hours. Like they show up, they unload everything, they hook it all up, and they're gone. And then now, if you miss that window of opportunity to coordinate your HERS rater and that installing contractor, it's a bummer. So this isn't like our, I put this in here. Paul says, please coordinate the HERS rater and installing contractor.
Yeah, the reason being, it'd be a lot easier for all of us to reduce the amount of effort to just verify refrigerant charge. This Fujitsu unit that's depicted there, say you've got one outdoor unit with 2 indoor heads, each mounted on a wall in a bedroom. So your line set, the sum of the line set is less than what's needed to add additional refrigerant. So you basically just need to be there that day and verify with the installer that he's not he's not adding or subtracting any refrigerant, because it's kind of pre-charged. If it's a different type of job and it's a large, this pretty much just apply to the mini splits that I see out in the field. One thing too, and if there's other raters on here, there's this thing about the permanently mounted thermostat on a wall. I've kind of been dancing around that, because the thermostats that they have are like in a little cup that's mounted on a wall, and you actually can take it out of the little holder and walk around the room with it. But I think for all intents and purposes, that is permanently mounted enough that it controls that particular wall mounted unit. So maybe there needs to be more analysis of the language the CEC is producing for that particular aspect of the measure. Question mark.
And then Paul touched on it too. Part of that credit, yes, the thermostat. So the little gray note is up there. Also, these units have to be installed within the air and thermal boundaries. And you need to show that there's airflow to each habitable room, i.e. each bedroom and the living area, to comply with that credit. And this example is an installation where it's a vented attic. And so the taped and sealed drywall on the interior of the walls, the ceiling, the floor, all of that was the air barrier, and then the insulation essentially is continuous around that by the ceiling, the walls, and under the floor. And then Paul has something to say about recessed ceiling ductless units. And still, these do also have to be within the continuous air and thermal boundary. So these are some ideas that I drew to help illustrate this to our architects to make sure that they're on board with what needs to be shown in the drawings, and then also what Paul is expecting to see on site to comply with this credit.
Yes, thank you. Maybe that's why Xavier was raising his hand, because the way the language is in the code is that it has to be in conditioned space. Every part of the air delivery system. So we've had to have contractors build an air impermeable box around that ceiling cassette, if you will. And that's not fun for some people, and you get a lot of pushback. But I think for a two-story house, you wouldn't have to do it because you're, say, on a lower story, because it's still inside the thermal boundary. I think down the line, we're going to see products being introduced that will address this issue. So I'm hopeful that that will make it easier for installers to comply with that particular portion of the measure.
And Javier, if you want to, looks like you're unmuted already, but if you want to go ahead and ask your question, go ahead.
Yeah, I had a question for Paul or the CEC. There's we're seeing a lot of jobs where the line set, it's being rolled up behind the unit because it's too long. And it's totally outside, just rolled up behind the unit. And I don't see anything where it's either a fail or it's okay. Obviously, they don't want to cut it. They want to save time with their hookups, and it's a terrible idea to keep it outside rolled up.
Well, if it's insulated and it's in the bed of the attic and it's covered with insulation, and then it goes into an airtight box, it would, I believe, my understanding is it would meet the intent of the code.
All right, the ones I see, they're totally outside.
Yeah.
Yeah. So.
But if
you mean outside the envelope, like just out?
Yeah,
like,
right next to the right next to the condenser outside, they'll have like.
Oh, wow.
Yeah. That's just bad. That's just bad craftsmanship.
Yes.
Yeah. I wonder though, if a city
as a
inspector
homeowner,
would,
I wouldn't be too happy with that.
Yeah, I would think that even the jurisdiction inspector would kind of say that's no bueno and have the installer correct it. But
yeah, okay. Well, let's
not technically a HERS measure, but yeah, it's good to point out best practices, right?
Yes.
So
yes,
not best practice.
Paul and I have a few more minutes to stay on if there's questions, or if we just want to unmute and just have a discussion. But given that we're hitting 3 o'clock right now, I want to let Sarah close out with some upcoming courses, and then we've got a few minutes that we, a few more minutes we can stay on. And it's always fun to talk to everybody. It's like we always get a nice crowd of folks who care about this stuff, which is great.
Yeah, thanks, Jennifer. Yeah, so I'll just run through these really quick. Again, just a reminder, we have AIA and ICC learning units, and I'll be sending out the slides and recording to your emails in the next few days. We have a few courses for the rest of the year. I've listed them out in December, and then I've also linked our overall main calendar as we are planning 2024. So we're starting to add courses for next year. So that will be updated in the next few weeks and next month or so. And I will go ahead and I launched a poll. This is the first time that this course has been offered. So if you can just answer briefly these questions, it just kind of helps gauge this course and future offerings. And yeah, with that, if for those that need to hop off, please feel free, but yeah, we can stay on a few more minutes and kind of run through some questions.
Great, because George made a comment, right, and then Paul was kind of typing back, and the comment was that the Passive House Institute trainers are saying drywall is not reliably airtight. Yet your variable capacity heat pump compliance option slide mentions the taped and sealed drywall as air barrier. So the California Energy Code, it does say that the drywall is air barrier. Craftsmanship is a lot of it, and also in that manual that Paul was holding up. And if you follow all the QII protocols and you actually follow proper air sealing, which California Energy Code does say that the buildings are to be air sealed, it's just we're seeing in the field that doesn't translate into actual like best practices. So some of that is making sure each piece of drywall is secured, sealed to the bottom plates, but the bottom plates are sealed to the floor, and it tells you you're supposed to do that, and you're supposed to put the sealant and up at the top of the drywall, so it's sealed to the top plates. And then now what we're seeing is a lot of folks in our milder climate areas are still trying to get away from exterior continuous insulation on the wall. A lot of times there's opportunities to have a better envelope that way. So we're totally on board. Like the slide that I had on the left-hand side, the thinking here, this one, unvented attic with a continuous air and thermal barrier. In this case, the idea was the sheathing had an applied air barrier that actually, when I do this presentation and I show the bottom at the foundation, we have that air barrier, which is adhered to the structural sheathing. It is secured to the foundation below the bottom plate. So that whole thing, that whole system is airtight. So,
excuse me.
Yeah, go ahead, jump in.
This is Josh Negrin with True Team. I had something on the air infiltration, but regarding this detail, I believe per 806.5, is this just showing both options, either the continuous above the roof deck, the minimum R5 for a climate zone, or, you know, the interior spray foam? Because 806.5 is one or the other, as far as meeting the unvented attic assembly. My understanding, at least.
Yes, for this, a lot of the climate zones, it's one or the other. For colder climate zones, you're going to be bumped up to an R10.
Mhm.
Yeah. For our climate zones, Tri-County area where we're working, Ventura, San Luis Obispo, Santa Barbara, the R5, or the 2-inch closed cell spray foam, which is giving you the R5. Yeah.
And also with the air infiltration, working with various HERS raters over the years, and more recently, that seems to be the area that there's a greater variance on what various HERS raters are looking for, as far as the air infiltration. So we've had people, HERS raters require us to foam the boundary of every stud bay. Others just want the seals and the beams, the cracks sealed along with the top and bottom plate. I've read through the QII handbook. I see there are multiple methods of meeting the QII requirements for air infiltration. Is that really pretty much up to each individual HERS rater, how to go about that? and this also goes back to my question about pre-con meetings. You know, we seem to be brought in after the fact a lot of times, whereas we would love to be part of that meeting or at least a job walk with the HERS rater beforehand, because everybody interprets the code a little bit differently. And if we can get on the same page with the HERS rater, it makes things go a lot more seamlessly for everybody through the inspection and installation process.
Yeah, I'll handle that one, Josh. Amen, brother, is my response. And let's wait till this train gets past. Can you see this graphic?
Yep.
Okay, so this addresses that issue of the caulking in every stud bay or whatever.
Mhm.
My interpretation of that, it says right here at the bottom, vertical stud shown here does not need to be sealed vertically as there's no seam. So in other words, say your exterior sheathing happens has a piece of two pieces of OSB coming like that, that would need to be sealed. But if
Right.
there's no seam there, it's pointless.
Yeah.
As a rater, my interpretation is what is, the boundary of the thermal envelope. And so I think some of the newbie raters are not interpreting it the same way that I would. And it just,
Right.
the noise has to be eliminated and eventually kind of figure out what everyone, needs to do to be on the same page.
Yeah, that's some of what I've run into.
Yeah.
And again, it's something we could probably work out in a pre-con meeting and
Yep.
get everybody's understanding on the same level.
I think it's all about the pre-con meeting, it's when they start pouring the slabs, let's get out there and walk it. Or, some of the walls are going up, whatever. Just have a grip and grin so that everyone can know who the players are and what everyone expects.
Absolutely.
I'm with you 100%.
All right, thank you.
Did that also answer the question, like who is right? And George, are you still on the call?
Yes, I'm still on the call. They had similar things to say about spray foam installation, and I'm noticing perhaps a little bit of controversy between using European materials and what's common here in the States, and that kind of getting possibly jumbled up with what you mentioned as standard of care within the trades, which is insufficient and which everybody's hoping will improve so that we can get buildings more airtight. I did have an additional question. Is there anyone offering a something like a Zender Plus, a Mitsubishi heat pump, where you're basically getting the benefit of the enthalpy recovery ventilator, and then adding that little bit of heating or that little bit of cooling that the system needs? Is that offered as a combination unit, or is it always separate?
I don't know about the heat recovery portion of it, but I'm not 100% sure on the small residential size on these ceiling cassettes recessed, but I know some of the ones we've used for hotel, motel, and commercial, you can have a small line that introduces your outside air to those indoor units, but I'm not sure you get the heat recovery like you would with the Zender or Renson system. So our experience has been that we've done everything we can to have well insulated, and even the refrigerant lines themselves be inside the house and insulated as soon as possible, not coiled up outside like Javier was saying. And also to keep everything within that thermal air barrier, envelope, and do a red line test just like they teach in the passive house training, and then introduce Zender or Lunos or other heat recovery for ventilation, and or even just other balanced ventilation. I mean, it could be life breath. It could be lesser expensive, but then introduce those systems. If we're going for certain credits, then it's tricky because the ERV, HRV needs to be on the CEC's registry, or rather, I'm not sure they're holding the registry. I might be have just misstated that. But when you look at the code requirement, those units need to be certified. And so I noticed that there's some new products coming out of Europe that are smaller, compact heat recovery that might be great for ADUs that would keep the cost down. They're not integrated, but you wouldn't have to go to the full expense of a Zender. And some of those just haven't quite gone through the certifications yet, so they're not listed on the registry that you could download from the CEC, but it looks like we're heading that direction.
May I ask
So-
also that other question I posted in the chat, if you look at what you have on the right in this slide, and you were going in trying to decide with limited resources, you've got enough money to either do the inside or redo the outside of the house. What is the stronger approach to achieve better air tightness and insulation, to basically peel the orange and peel the skin off and then re-insulate, remembrane, and refinish? Or is it perhaps more economical, maybe just as strong an approach to go in from the inside?
That is a good question. And that is it's like all depends. I'm working with an architect right now who's decided for their particular project, they're doing everything from the inside, and they're going to go in and try and seal as much as they can with the closed cell spray foam up in the attic. They're going to convert it. They're going to change it to pulling it into conditioned space. And then they're looking at using aero barrier and having that thing spray inside this existing house, because they're going to keep all the outside. And then I've had clients where I have a client right now where the outside of the house is T111 plywood, and it's just a lot of the areas of the nailing, a lot of them is just rotted. And so the structural engineer, we thought we were going to save a lot of it. Structural engineer came up and looked at it and said, you know what, there's hardly any panels that are going to be left. And so the builder decided the best approach was just to pull all that siding off. And so once they did that, then they're going to go ahead and resheath it and follow along with all the Mentos, Gutex products, and just really do it like that, you know, and have a continuous air barrier all on the outside, and then do Gutex and a new party siding product with the rain screen. So I think it depends. I don't know if that helps.
I think what you're saying, I think the big question is, you know, what really works for a particular structure. And
Yeah.
I like what you said about asking the question of where is the deterioration and where is the real value to be recovered as you're moving forward retrofitting. So thank you.
Yeah. Yeah. And in my own old house, it was the floor. The floor was leaky as all get out. And so we had a popcorn ceiling. So we dropped the ceiling onto the old carpet and rolled up the old carpet with the drop ceiling and put it in the trash, and then went through and just said, okay, we're going to do it all from the interior. Still, it'll be a vented attic. We'll add more insulation in there, but we went in and just everywhere we could, we tried to air seal it all, you know, as from the interior. So we air sealed the floor and then put in a new flooring and did the ceiling, et cetera, et cetera. I think it just depends.
All right. Well, so we are about 15 minutes
Oh, yeah.
after 3. So thank you all for staying with us and all of your great questions. If you have any other questions, I went ahead and added our Energy Code Coach web form link into the chat. So you can submit a question and it'll get submitted to us, and we'll get those questions answered for you. But with that, I'll go ahead and end today's course. Thank you, Jennifer and Paul, for a great session, and hope you all have a great rest of your afternoon.
You're welcome, everyone. Thank you, and you're welcome.
Thank you.
Thanks, everyone. Bye.
Bye, all.